Hello, my name is Karina, and I recently completed my studies at ETH Zurich and joined the Computational Life Sciences group here at the ETIS Foundation. I am working on studying interactions between electromagnetic exposures and biophysical and physiological responses for therapeutic or exposure safety applications. Topics of interest include the design of bioelectronic implants and MR implant safety. I have been using the student desktop version of Sim4Life for my simulations. Lately, I have also been working a lot with the full version of Sim4Life. I am actually a big fan of Sim4Life as I found it to be the best tool for complex simulations, outperforming all other tools I tried. However, due to the low performance of my laptop, I kept running into problems. I was therefore very excited to hear that an online version of the student desktop version of Sim4Life has been released that offers the same or better performance, even on a tablet, when loading, manipulating and adding complex implants to the detailed anatomical human models, including bird cages, and that without installing any software, just a standard web browser. Let's test this. The new student web version is called S4L Web Lite. Everything happens in the cloud, utilizing the computational capabilities provided by AWS. Sim4Life can simulate a wide range of physics and supports detailed anatomical models. It comes with extensive tissue property databases and dynamic tissue models, as well as a wide range of specialized tools, and there are many tutorials available to showcase them. Applications range from electromagnetic radiation and propagation basics to complex tasks like millimeter wave antenna design. This includes beamformation by a patch antenna array and evaluation of power density impinging on a nearby phase. Another tutorial shows how to use Sim4Life to evaluate the specific absorption rate in a standardized setup. Another application is the simulation of magnetic resonance imaging coils, where Sim4Life is used to improve B1+ homogeneity of a birdcage coil for improved imaging quality and to evaluate the power deposited on an implant in an ASTM Phantom, a standardized setup for implant safety assessment. There are also tutorials for applications involving complex tissue models, such as electric stimulation of a single neuron and neural networks. Also thermal, flow, and acoustic simulations, and many more. I wish I had had such an amazing tool when I did my master's thesis, but let me show you how your master's thesis could look like now when having Sim4Life Web Lite available. Let's look at a topic that is currently of high interest to my research group: temporal interference stimulation. Temporal interference stimulation uses two intersecting currents at frequencies that on their own are too high to elicit a neural response. However, because they have a slight frequency difference, a low-frequency beating effect ensues, which affects neuron activity. Here I want to see if it is possible to use TI stimulation to non-invasively and selectively stimulate the median nerve in my forearm, without causing pain, sensation, or muscle twitching near the electrodes. Various strategies are possible. I could place the electrodes in series, in parallel, interleaved, or in a nested arrangement. To predict the most effective arrangement and optimize the electrode placement, I am placing two sets of electrodes on the forearm of the Yunsun model that is part of the S4L Web Lite offering, and perform electromagnetic exposure simulations for each channel. Built-in advanced post-processing functionality permits to compute the resulting TI exposure, which I can subsequently use as stimulation source in a neuronal dynamic simulation. Here you can see how the induced spiking activity and signal propagation is predicted to result in a measurable surface potential. One of my colleagues has in fact applied the optimized TI stimulation configuration and was able to elicit controlled finger motion. To conduct my research, I have utilized Sim4Live as a simulation platform, building on top of the existing Yunsan ARM tutorial. With Sim4Live abstracting away many of the tedious steps involved in the simulation process, I have been able to focus on the scientific aspects of my research, such as optimizing the simulation device for a more realistic human anatomy. By utilizing Sim4Live, I have been able to gain a deeper understanding of the underlying mechanisms and make informed decisions regarding the design of the simulation device. I am really impressed. The S4L Web Lite is very responsive. Compared to the desktop version, I did not notice any substantial difference when performing advanced computer-aided design modeling, rendering detailed 3D anatomical models, or performing and evaluating full-wave electromagnetic simulations. The web version has many impactful advantages, one of which is that I do not need to install any updates as everything is now managed by ZMT, the owner of Sim4Live. In addition, all my projects are available anytime and anywhere. The web-based version permits me to share my studies with other students without moving files, and offers a great way for collaborative modeling. This opens completely new possibilities for joint projects. Plus, it's completely free for students, including the AWS resources and time, which is absolutely great. For me, that's a 5-star rating. Thumbs up for S4L Web Lite. Thank you for watching this video. I hope you have enjoyed it and that you are now curious to explore S4L Web Lite yourself.